Hello, my name is Zahra Alumari, and today I'll be discussing the role of hydraulic service in the environmental performance of Building 410. Hydraulic services in the built environment is concerned with the flow and the conveyance of fluids, principally water and sewage. Today, designers must be able to recognize a building's potential environmental impacts and establish whether the methods taken to deal with them meets the Australian building standards. Environmental performance stipulates a measure to which buildings might influence their environment in order to minimize harm and improve amenity. In this assessment layout, the basic literal knowledge and understanding of the chosen system has been brought together to analyze its role in the environmental performance of Building 410. This will be demonstrated through observations, methods, and discussions such as existing hydraulic services, proposed hydraulic services, which will be categorized into drainage system, sewage system, stormwater system, grey water system, portable system, and fire system. I will also include recommendations and lastly conclusion. In Assignment 1, Building 410 was redesigned with a new structural system called Engineered Structural Timber, or known as CLT. However, in this assessment, we are required to study the chosen active service and how it may impact the proposed structural system of the building. This diagram shows the existing hydraulic services of Building 410, which include fire water, cold water, hot water, and drainage. This diagram shows the new proposal for Building 410. It starts by potable water, which is hot and cold water, used for washing, which will then turn into grey water. Once the grey water has been used for toilet flushing, it will go through to the sewage. On the other hand, the stormwater goes through a filter and will be used for fire water system. Once it has been used, it will go straight to the sewage. The proposed changes are aimed to improve the water efficiency and the environmental performance of Building 410. So the proposal plan includes proposed grey water system from washing and flushing, review standards and legislations regarding hydraulic services and public toilet facilities, identify opportunities to optimize water and waste efficiency, upgrade existing facilities to comply with regulations and environmental concerns, works within proposed building changes from Assignment 1 and 3, reduces maintenance issues, water quality, fire hydrant, fire hose reel coverage, alternative firefighting solutions, stormwater treatment, industrial waste pre-treatment, health and safety of building users and operators, whole of life consideration, and lastly material selection, availability, recyclability, maintainability, and disposal. So the relationship between hydraulic service and electrical service include requirements for supplies such as location, termination, size, phases to all hydraulic equipment, requirements for fire indicator panel interfaces and fire alarm indication, requirements for plant room, fire pump room, and external plant deck lighting and service. PowerPoints, requirements for data points for connection to BMS controls, requirements for all gas safety equipment and interface with BMS, requirements for fire pumps and equipment, alarms, electrical power supply to pump, switchboards, hot water units, boiling water units, ice machines, etc. Drencher flow switch, provision of hydraulic services for fume cupboards, cool rooms, etc. And lastly, provision of ceiling access and access panels where required. And the relationship between hydraulic service and mechanical service include requirements for condensate drains, waste, and overflow from mechanical equipment, requirements, location, and size of ton dishes, types and temperature of discharge from mechanical equipment, requirements and location for plant room drains for mechanical equipment, requirements and location of water supplies to mechanical equipment, and lastly, sprinkler systems. I also suggested mechanical flexible couplings, which is basically slabs and footings require mechanical flexible couplings for subsurface drainage pipes and for above ground connections from downpipe to the stormwater and sewage drains. This basically reduces the potential of broken pipes in highly or extremely reactive soil. Recommendations. 1. Mains water cannot be used for irrigation purposes. 2. Cold water only shall be supplied to students, staff, and universally accessible toilets. 3. Any processed water system supplied from mains water shall be designed as a closed-loop system. 4. Incorporate leak detection through the BMCS within systems where considerable water losses may be likely. 5. Rainwater harvesting and reuse must be considered for all projects and applied where feasible. 6. Reducing potable water demand through water-efficient appliances. 7. Minimizing wastewater generation and treatment of wastewater to a standard suitable for efficient reuse and or release to receiving waters. 8. Passively treating urban stormwater using biofiltration and wetlands system to meet water quality objectives for reuse and or discharge to surface waters. 9. Using stormwater in the urban landscape to maximize the visual and recreation amenity of developments. 10. Greywater must not be reused where expensive wastewater treatment involving significant inputs of energy, chemicals, and high maintenance is required. Thank you for listening.